Okay, so our first example involves the first kind of factoring that we went over when we were doing our review. And this is the kind of factoring where you've just got two terms, right? Now, the very first thing you need to do before we do this, before I get ahead of myself, is you have to always, when you're factoring on an equation, you have to always get one side equal to 0, right? And so you have to make sure that everything is on one side and that there's nothing on the other side, because the whole premise of this working is that we have to get two things or more that multiply together to equal 0. Well, if you've got something on the other side, it doesn't equal 0, does it? Nope. So we want to get it to that point. So that's what we're going to do here. We're going to make this equal to 0. And if it is, then you've bystepped. You know, you've bypassed that first step, right? Bystep is not a word, Mr. Simons, all right? But bypass is. And so now when you have it to this point, right, you have to ask yourself, okay, what kind of factoring do I need to do, right? And so in this case, it's just I can use my greatest common factor and just pull it out of both of these, right? I don't have three terms, so I don't have to do any screwing around with the AC method or any of that. This one I can just go right to pulling out my GCF. So if I look at this, the largest thing I can pull out is I can pull an 8 out for my number, and then I have an x squared and x, and so the most I can pull out that will go into both is 1x, right? That's the whole idea of a greatest common factor. It's the largest thing I can pull out without going over, right? And so then this gives me 2x, because 2 times 8 gives me my 16, x times x gives me my x squared. And then if I want to get to 8 from this to this, right, well, if they're exactly the same, you just use your identity property and multiply it by 1, right? You get 0. All right, now I'm going to use the 0 product property. Okay, so if you want to think of this like this, right, maybe that will help you. But this is either equal to 0 or this is equal to 0 or both, all right? And so we've got case 1 where this is equal to 0, or we have case 2 where this is equal to 0, or both. And I'm not going to write both down, because if you solve one or the other, then you've got them if you need them. Okay, so you have 8x equals 0. Well, if we divide both sides by 8, right? Again, this is actually a case of 0 product property too. I know this has to be 0, but I'm just showing you using our usual procedures, right? 0 divided by 8 is 0. So you have the one case where x could equal 0. And then this case right here, 2x plus 1 equals 0. We are going to first subtract 1. I don't know why I rewrote it, but I felt the need. So there's 2x equals negative 1, and then you divide both sides, right? You're usually adding or subtracting first and then doing a division step on most of these. And you'll get x is equal to negative 1/2. And so your solution set is x either equals negative 1/2 or 0, right? We can write it like that. Okay, and those are my solutions. Those are the roots to the equation, okay, to this equation. And if you put this in a graphing calculator or Desmos or something like that, you will see that it goes through the x-axis at these points, right? That's the whole way we know something like that works. All right, this one. So now we are back to our roots here with factoring with the AC method, okay, which we did a lot of in the past couple days. All right, and so we just got to remember the AC method is where you multiply your A and your C term. All right, so this is C. My A is 1. All right, and so I'm going to go 1 times 20, and that's going to give you a number that you're going to factor to see if you can find two factors that will add up to your B term, right? And we want that to add up. So add up to B, right? And B is 9. So for 20, that gives me positive 4 and 5. So I want to get to positive 9, and 4 and 5 are the factors that jump out at me right away, and if I add them together, I go 4 plus 5 equals 9. So that's definitely what I'm going to use is these two factors. And then your next step is to decompose your b term. All right, so we're going to go plus 4x plus 5x, and then finish writing your equation out. All right. Now, factor by grouping, same as always. Pull an x out of these first two. All right. Think of it like this, right? You got a little fence. And then this one, I'm going to pull 5 out of both. Going a little quick on this step because we've done this, all right? And if you need to see more of this, if you're still struggling with this part, then by all means, go back and watch some of those videos. All right, so x plus 4 is a common factor, so we pull that out of both. And then your leftovers, as I like to call them, right, your x and your plus 5, are going to go in the other one. And so now I have two binomial expressions that multiply together to give me 0, right? So my first case is I have x plus 4 equals 0, and I have x plus 5 equals 0. If I'm going to find the solutions to these, right, the roots, these are the two things I'm working with. So this one, you subtract 4, and you get x equals -4. After a while, you're going to see these, and you're going to be able to go very quickly to the solution, right? Because you'll do enough of these, and you'll be like, oh. So you got x equals -4, and you have x equals -5 by doing the same process we did over here. Subtract 5 from both sides, and you get that. And so my solutions, my roots, are x equals -5 and -4. I usually write them in numerical order from least to greatest. All right, we can write that with my set notation, and you have solved this. So we'll have one more example in another video, so stay tuned.